Hey guys, welcome back to my channel Cloud Tech Services. Imagine you have two offices. One office has your finance team and the other office has your application team. Both teams are working for the same company, but they are sitting in different buildings. Now, what if the application teams needs to securely access a database used by the finance team? Exposing the database to the internet can be very risky. A very complicated VPN setup could be established for achieving this, but a more simple method is available and can be established using an Azure to Azure connection. So, what should be done? This is where Azure Virtual Network Peering comes into place. By the end of this video, you will understand what is Microsoft Azure, what are Azure Virtual Networks, why Azure networks are isolated by default, what virtual network peering means, how two Azure virtual machines can communicate privately, types of virtual network peering, how the traffic flows after the peering is completed, and some limitations that you must remember. So, let's start with our basics. Before we talk about virtual network and peering, let's first understand very quickly what Azure is. Microsoft Azure is a cloud computing platform from Microsoft. It allows us to use computing resources through the internet. Instead of buying physical servers and keeping them in your own data center, you can create and run these resources in Azure in minutes. Some examples could be virtual machines, databases, storage accounts, web applications, firewalls, Kubernetes, Docker, and many more. Once the Azure resources are created, a very important question is, how do these resources communicate securely? To solve this, Azure provides a very important network component called the Azure Virtual Network or Azure VNet. What is an Azure Virtual Network? Azure Virtual Network is like our own private network inside of Azure. You can consider it as a private building inside Azure. In this building, you can place your virtual machines, databases, application gateways, private endpoints, and other Azure resources. A virtual machine network allows these resources to communicate securely with each other. A virtual network can contain multiple resources inside it, such as virtual machines, subnets, network interfaces, private IP addresses, firewall rules, load balancers, etc. Each virtual network has its own private IP address range, just like a network in a traditional data center. These networks are separated by default. That is, resources hosted on one virtual network cannot automatically communicate to another virtual network. Now, these Azure virtual networks are isolated by design. This is very important in terms of security. Resources in a virtual network A cannot automatically communicate with resources in virtual network B. This isolation protects the environment. But in some cases, we need to have communication between the resources inside two different virtual networks. With virtual network peering, two Azure Virtual Network can be connected so that both resources can communicate with each other privately using private IP addresses. It would feel that both the networks are part of one large private network, even though they are still separate virtual networks. So, what is virtual network peering? It is a feature that allows us to connect two Azure virtual networks. Once peering is created, resources in both virtual networks can communicate with each other using private IP addresses. After peering, the traffic does not need to go through the public internet. It stays on the Microsoft backbone network. This gives us better security, better performance, lower latency, and high bandwidth for communication between the two different resources. Why do we need virtual network peering? There are multiple benefits of using virtual network peering. The first reason is private communication. Instead of sending traffic to the internet, the virtual network peering communication allows using private network. The second reason is better security. The resources communicating through the virtual network peering are not exposed to the internet and they do not need a public IP address to be accessed. The third reason is cross boundary design. Virtual network peering can be established across different subscriptions, resource groups, and even Azure regions. The fourth reason is low latency and high bandwidth. Since the traffic uses Microsoft's private backbone network, communication is faster and reliable. This is very useful for applications that need quick communication between servers. And last but not the least is the hub and spoke design. In this design, there is a central network called as the hub. The hub may contain shared services like firewall, VPN configurations, DNS servers, etc. The other virtual networks are called spokes. Each spoke may contain different workloads like web applications, databases, testing servers, or department specific systems. Each virtual network peering, the spokes can be connected to the hub, which makes the network easier to manage. Types of Azure Virtual Network Peering. There are mainly two types of peering. The first one is called as the local network peering. This is used when two virtual networks are residing in the same Azure region. The second one is global virtual network peering. This is used when two virtual networks reside in different Azure regions. The global network peering requires permissions to work across subscriptions and tenants. This also supports the hub and spoke configuration and the service chaining. Global virtual network peering is used for companies that have applications running in multiple regions. It helps connect resources across regions privately. It is very useful for disaster recovery, global application, and multi regional architecture. Virtual network peering can also work across subscriptions and tenants if proper permissions are available. This means different teams or departments can still connect network if they are allowed to do so. Let's now understand what happens when the virtual network peering has been created. When we peer two virtual networks, Azure automatically adds system routes for the remote virtual network address space. Let's make it a little bit simpler. A route tells network traffic where to go. If virtual machine A wants to reach to virtual machine B, Azure needs to know the path. Before peering, virtual machine A doesn't know how to reach virtual machine B. After peering, Azure adds a route. For the example here, virtual network A has an address range of 10.10.0.0/16 And virtual network B has an address range of 10.20.0.0/16. After peering, Azure adds a route so that traffic from virtual network A goes through VNet peering to 10.20.0.0/16, and similarly, traffic from virtual network B to 10.10.00/16 also goes through VNet peering. So when virtual machine A sends traffic to virtual machine B, Azure checks the route and forwards the traffic through the peering connection. This happens automatically. No manual effort is required for adding the peered virtual network address space into the route. Let us now see what are the requirements for creating a virtual network peering. The first and the foremost requirement is the two virtual networks that are supposed to be peered together should not have overlapping address space. There should be there should be no overlapping address space for the virtual networks. Virtual networks in consideration should not have same address space because Azure will not know which network should receive the traffic. Second, there should be proper permissions. If both virtual networks are in the same subscription, this is easier. But in case we are setting up global virtual network peering and the virtual networks are in different subscription or tenants, proper access is required on both sides. The third, network security rules should allow traffic. Peering only allows network connectivity, but it doesn't automatically open all ports. Network security groups and ports on firewall still need to be configured correctly and manually. And fourth, if gateways are being used, gateway rules should also be considered. A virtual network can use a remote gateway in only one peering. Also, a virtual network cannot use a remote gateway if it already has its own gateway. Having said that, let's talk about few key limitations of virtual network peering. The first limitation of virtual network peering is that it's non-transitive in nature. For example, if virtual network A is paired with virtual network B and virtual network B is paired with virtual network C, it does not mean that virtual network A is also paired with virtual network C. If virtual network A needs to talk to virtual network C, a direct peering must be established between virtual network A and C. The second limitation is that Azure Virtual Networks should not have overlapping CIDR ranges. CIDR means the IP address range of the network. Two paired virtual networks must not have overlapping address spaces. For example, if both networks use 10.0.0.0/16 address space, you cannot pair them. The third limitation is that the DNS is separate. Azure default DNS does not automatically resolve names across paired virtual network. For name resolution across paired virtual network, Azure private DNS or custom DNS server might be required. The fourth limitation is the gateway rule. A virtual network can use a remote gateway in only one peering. If a virtual network already has its own gateway, it cannot use a remote gateway. And the final limitation is the scale and cost. There is a limit to how many peering a virtual network can have. The virtual network peering traffic may have a small ingress and egress charges. So that was all for today's video. We'll come up shortly with another video where we will look into how we can create virtual networks and how we peer them. Till then, stay with us. Do like, share and subscribe my channel for more such videos. Thank you for watching.